Welcome to another Adafruit Wearables Teardown, everybody. Today we're looking inside the Twerkle shirt by Cute Circuit. It's the first straight up fashion design we've taken apart, and inside it's got these embedded color changing LEDs that light up and flash in reaction to movement. And the main shirt's even machine washable. The brains of the operation snaps into the shirt, and the sandwiched acrylic enclosure reminds us of the Pibo by Pimeroni, another London-based company. By cutting into the shirt, we revealed the flexible PCB running diagonally up the length of the design. The whole front of the shirt is made of bonded layers of fabric with the circuit secured between them. Exploring how this garment was put together was pretty interesting. Let's see what Lady Ada has to say about the hardware inside.
Okay, so we've pulled out the heart brains of the Cute Circuit t-shirt, and it's got a little circuit board with the snaps, and the snaps are what make electrical connection into the t-shirt. So this allows you to pull it out while you wash it, or if you're it's super rainy out and you want to not have the circuit and the power connected, you can just snap it out, and it's powered from a LiPo battery. So 250 milliamp hour LiPo battery is rechargeable through the USB port. And on here next to the snaps are all the circuits. So let's check out what's going on under the microscope, because these are some pretty small parts. In the center of the circuit board, surrounded by those little snaps, is a chip, and if you look carefully, you can kind of make out it says @Mega 168, looks like. So it's probably an @Mega 168, which is sort of a half-size Arduino chip. So probably used Arduino to prototype this project, and then they're like, well, we don't need the full Arduino or micro, so we just took the chip and stuck it on the circuit board. And then over here is a little chip that says 7331. That's an accelerometer. It's a triple axis digital accelerometer. We've seen this in a lot of projects. It's what detects motion and then translates that motion into sparkles or twerkles or twinkles. We've got a couple breakouts here. This is a 6-pin. I guess that's an ICSP connector. That's your standard AVR programming port. If you want to reprogram this or maybe modify the code, that's probably where you want to connect. Here is a little chip. Little 5-pin chip over here and a couple 5-pin chips over here. And then over here, this is almost certainly the regulator, because there's a 33 on it. Usually that means it's a 3.3 volt regulator. And then down here you see TWI, that's 2-wire interface. So positive, SDA, SCL, ground, classic, maybe for connecting other kinds of sensors or circuits. You could have a gyroscope or something, or a barometric pressure sensor or temperature sensor attached. And over here is SEER for serial. So that's again voltage, RX, TX, and ground. Maybe for debugging, or maybe you program it. Side LED for maybe battery charging. And a couple more breakouts here. I guess they didn't use all the pins, but they still wanted to have some of them broken out in case they needed them. So there's an extra ground pin over here. And you can see each one is labeled D6, D5. So that's the port D6, port D7. So these are actually pinouts. These are little driver chips, little transistors, maybe either for protection or for driving a little bit of extra current. And then these snaps are snapped on the back. So they're actually a mechanical connection, which I think is interesting. It's not soldered on. It looks like they actually riveted those on. The battery connects over here, and here is that USB mini port and the reset or control button. And then on the other side of the connection, if we look over in the t-shirt, we have the snaps, and then the snaps snap into a flex PCB. So that's the other side of the connection. Flex PCBs are hard to solder to, but maybe they just crimp soldered the other side of the snap to it. We have to cut this to take a look at the entire circuit. But you see there's a couple connections here, one for each pad. And they go down this long flex strip and down each strip to a little miniature LED. This is a teeny, teeny, teeny RGB LED. You see there's 4 connections, and then it says 18 or 100 ohms and 18 ohms, 18 ohms. So it's the red, green, and blue. So these are not like NeoPixel LEDs. These are just plain RGB LEDs. They're either multiplexed or Charlie-plexed, so that you can have 3 or 4 of these LEDs down the flex circuit. Probably what they do is the red, green, and blue pins are connected together, but then they change what the power ground pin is so that they can cycle through all the different LEDs in order. Since they're not smart LEDs, they have to actually multiplex each LED. That's probably why they need a fairly beefy processor here. And then on the shirt itself, the LED fits behind this piece of fabric, and there's a little white spot that's actually kind of rubbery, and it's actually a diffuser. So this is where the LED fits behind, right here. And since these are very small LEDs, they're very good point sources. We want to diffuse it if you want to make it a little bit more visible, so it's not blinding, but you can actually see the effect. So it's kind of an interesting idea that they put the diffuser, instead of putting a glob of glue or hot glue or epoxy on here, they actually put the diffuser into the fabric. So it's a pretty simple circuit, but still has a lot of high technology in it. Has a Arduino chip, has an accelerometer. Looks like it's designed so maybe it could have other sensors or technologies attached to it, possibly adding a Bluetooth Low Energy capability at some point, the serial port or the I2C port. So here you go. This is your first off-the-shelf LED t-shirt we've taken apart. Hopefully we'll be more glowing LED t-shirts in the future.
For this and many other teardowns, we use these tools, including the Adafruit USB microscope with its articulated stand. What wearable tech should we take apart next? Leave your suggestions in the comments and subscribe for more wearable electronics from Adafruit.